Welcome to Coding with Scratch Challenge 2. This is the Maze Game Challenge, and this video will get you started. In our first challenge, we learned how to make a chasing game. Our maze game is fairly similar, but we'll introduce a few key concepts. One of them is making a wall. In a maze game, we've got these walls drawn on our screen, and we have to tell the computer, of course, that these things are actually walls. See, a computer doesn't know the difference between a wall and a pretty picture, so we'll use scripting to make that happen. We'll introduce a timer, and having the time run out on a player. We'll also introduce the idea of levels, so we can have multiple levels in our maze game. Those are three very important gaming concepts that we'll learn in this challenge. Let's go ahead and get started on our maze game. This is actually a really cool exercise. I think you're going to be really excited. It's a fun time. This is one of our favorite exercises here. Okay, so here are our backdrops. We have Maze 1 and Maze 2 backdrops already drawn here. I just used the drawing tool to create these, and the key is to draw all the walls with the same color because we're going to use that color as a way to know when we're hitting a wall. You could also import a maze if you want to. I created sprites called Start Spot and End Spot, again with the drawing tools. By the way, if you want to name your sprite, just hit the info button on the sprite and then you can name it anything you want. It's probably a good idea to name your sprite so it helps you stay organized. For the runner, I've got a number of costumes that allow me to animate him. I'm not going to talk about how to do that right now, but we'll put something about that in the hints video. So let's talk about scripting this. Like last week, we need to have a script for our arrow keys. So again, we'll create an arrow key script that points in a certain direction and lets us move 10 steps. Now the key to the walls is that if I make a move and I hit the wall, then that move has to be disallowed, and the way to do that is to use an if statement that says if whatever. And then I'll use my sensing block that says if I'm touching whatever color, something happens. The way touching colors works is that I've got a little swatch right here, and I click on the swatch and then click on the color I want, and now it says if I'm touching the purple color, which means that I take this step with the right arrow and then I touch that color. That's bad, and I should avoid that. So in order to negate that move, I'll simply move backwards 10 steps. Great. So now I've got my right arrow key and I cannot move through the wall. I need to do the exact same thing for all my arrow keys. And so if I do a right click, I'll use the duplicate button and I'll copy those moves. So I've got all my arrow keys here and I'm ready to start the game. To do that, I'm going to use the green flag, which is under the events. We'll do something different here. Instead of the green flag script running everything, I'm just going to have the green flag broadcast a message. I'll broadcast the message start, and then everything will happen when the sprites receive the start message. And the reason I'm doing this is because there's no way to make the green flag happen, but I can broadcast the start message anytime, so it allows me to restart the game whenever I want to. The broadcast system allows you to send messages from one sprite to another. You just create any message you want by typing a new message here, and then that message gets sent and all the sprites can receive it with this receive event. Very simple and it's very interesting. So I've got receive. Now there's a few things my sprites need to do at the beginning. The first thing is they need to go to the proper location. That's where our start spot comes in. I can use this go to command here and just go to the start spot. Perfect. We also want to be able to start the timer. You can see the timer here in the corner. It's blue and under sensing. So if I scroll down here, you'll see there's a little checkbox next to the timer. If I turn it off, you can't see the timer. If I turn it on, you do see it. The timer runs all the time, so don't let that bother you. It keeps running, and the one thing you can do is reset it when you want it to be 0. So I'll select a reset right when I get the start message. I might say something at the beginning of the game like "here I come" or something like that. That's up to you. We need to be checking to see if we won the game or if the timer has run out, so I'll use a forever loop for that. I've got my forever loop here, and we need to do sensing like we did before. Our sensing will use an if statement, so I'll sense if I'm touching the end spot. Right, if I've touched the end spot, then that's the end of the race and I've won. So that's the player's goal, to get right there. Awesome. On the other hand, we need to see if the timer has run out. Now the timer starts at 0 when we begin, so I need to find out if the timer is becoming greater than something. So all the greater than and less than operations, which are these green colors here, we haven't used these yet, so I'm going to grab greater than, less than options here, and I'll go back to sensing. I need to grab this round timer option, which is the timer variable. So it keeps the number that's in the timer in this variable here. So I'm seeing if the timer is greater than whatever. We have to set a time limit for this maze, and so let's say 30 seconds. The timer measures everything in seconds, so if it's greater than 30 seconds, that means the time has run out on the maze game. This kind of stuff is really useful for programming logic too. I'll highlight one last thing to do, which is to make sure that all the sprites are responding to the start event at the start spot. So when I get to my start spot, I'll need to go to the current location, and also when it gets to level 2, it will need to go to the level 2 location, which depends on where your sprite is. You can also put a similar script in the stage itself, so the stage can respond to the start message and make sure it's showing the correct backdrop for your level. So you've got these real short little scripts that are vital. All these things have that same sort of script to make sure everybody's in the right location for each level. Okay, so the rest is up to you. We'll post some hints later in the week. Good luck with Challenge 2.